All right, let's go over your type 1 and type 2 errors and see if you got those worded correctly and the correct consequences. So, on this first problem, we were wondering if there was job discrimination against minorities and women. So, a lot of times I like to put in layman's terms the way that the null and alternative, what they're really saying. So, what's happening is if the proportion of newly hired and the proportion of applicants of minorities and women are the same, then there's not discrimination by the company. But if the hired minorities and women is less than the applicants that were minorities and women, those proportions, then the company is considered discriminating. Okay, so in context, describe a type 1. So HO is true. So the reality is there is no discrimination happening. Okay, so the proportion of hired minorities is equal to the proportion of the applicants that were minorities and women. But we rejected it. We got a sample that made us think that the company was discriminating. So the HO is true, there is no discrimination, but our sample makes us think that the company is discriminating. So, of course, a consequence of this error is that the company is could get sued. Okay. Well, they're accused at the very least, maybe sued for discriminating when they really are not discriminating. Okay. Type 2 would be that opposite situation where the reality is that they are discriminating. The proportion that of men and women, or sorry, the proportion of minorities and women who were hired is less than the proportion of minorities and women who applied, but our sample was not far enough out there and did not give us evidence of that discrimination. So we did not reject. We failed to reject the false null hypothesis. So we don't think there's discrimination. So the consequence, of course, is that the company is actually discriminating, but we did not detect that. So women and minorities are not getting hired at the rate that they should be getting hired. So, which type of error would the company consider more serious? Well, I would imagine type 1 because they certainly do not want to be accused of discriminating when they are actually not discriminating. Okay. Now, which type of error would the minorities and women consider to be more serious? And I think that would be a type 2 because they are not getting hired. The minorities and women are not getting hired at the same rate as the Caucasian males, and we weren't able to detect that. All right, next is the problem about a new medication. Okay, so we're wanting to fight these infections. Maybe we know that this new medication is going to help. However, it could be highly toxic, not topic. Okay, that was a typo there, but toxic. So you're going to test this medication for its toxicity. Okay, and so our parameter of interest. So, of course, our proportion of patients that were found that the new medication was toxic to them, hurt them. Okay, so of course, the null hypothesis is that we do not have toxicity. So that's actually a good thing in this case. So it's kind of interesting. Um, so not being toxic, but do we have evidence? You know, the alternative, do we have a high enough proportion that we say, oh, this is significant, and it seems as though we have a highly toxic medication, okay, one such that we would then not want to use it, even if it has benefits against the infections. Okay, so type 1. Type 1 error, then if the null is really true, but we get a sample that causes us to reject. So the reality is that the null. So the reality is that the medication is good to go and is not toxic for the patients. But we had gotten a sample, we had enough false positives or whatever that it makes us think that this new medication is toxic. And so what happens is, you know, we don't get to benefit from that new medication that helps fight off infections because we think that it is too toxic to continue to use. So we lose that opportunity to get to use that medication. All right. But our type 2 error, of course, is going to be the opposite, where we have a false null hypothesis. Null hypothesis is false, and we fail to reject that false null hypothesis, okay? So the reality is that it should be rejected, and that's because the medication is toxic. Okay, it is too toxic that, and we should not use it on patients, but we failed to we failed to detect that. So we think it's not toxic, and we're like, woohoo, okay, let's use this medication. Yet we find that it is really causing problems. Have you seen all those commercials about lawsuits that the FDA approved something and then it actually caused these other problems or whatever? So the consequence, we think that this medication is working well and it's not causing other problems, being toxic. So the new medication gets approved, but it really is causing harmful effects on the patient. So which type of error would the doctor and the patients consider more serious? Probably, I mean, type 1 would be bad in that, you know, we fail to find the good in we missed an opportunity. Okay. And so that would be bad in that you're missing an opportunity to use that medicine that really does help and isn't toxic. But I think even worse, though, than a missed opportunity would be this situation where if we approved that medication and then it causes bigger problems, it has a toxic effect, causes liver failure or whatever, and we're just trying to fix an infection. Okay. Which type of error would the pharmaceutical company? Well, they would definitely hate that they have a product that works, um, and it's being falsely accused of being toxic. So that's that type 1 error. So the pharmaceutical company would definitely be upset if they're being falsely accused of being toxic. Okay. And our last one here. So I kind of had to give you some leading information in this prompt where you are a new engineer and you have a new manufacturing method to create this item that takes less time. So that then, of course, in the long run, could save you money, could make you more money, could give you more profit. Anyway, those different kinds of things. So you want to try this out and you think that we've got a situation that can help your company. So, but the problem is that we're going to test it out, okay? But if we decide that on a small scale that it works, then they will shut down the plant. It's actually quite expensive process to retool the entire factory or the entire plant to change over. It is actually quite expensive. And there's a lot of downtime, and so it's quite costly. But if this method is effective, and then it will, in the long run, save the company money or make the company more money than ever before. So let's see. All right, so our mu is the average length of time that it takes to make these widgets. And of course, currently it's the average is at 75 seconds, but with the new tooling, if the new tooling works, we think that will be less than 75. So let's see what happens. In context of for a type 1 error, okay, the null is true. So that means that the new method is not having a benefit, no benefit, okay? That new process doesn't actually help by reducing that time, okay? But look at what happens with a type 1 error. The null is true if the null is really true, but we get a sample that causes us to reject the null. That's a type 1 error. So we reject the null and we are thinking, hey, this is going to improve our profit. So it is worth the expense of retooling the factory. Well, they think the new process works, and so they are going to then go ahead with the renovation on the factory. So the consequence is that the company wastes a lot of time and money retooling this plant for that changeover to that new method when there actually is not a benefit from that expensive change. Okay, that's going to be quite a bit lost and a pretty significant impact to that company. Now, type 2 course, the null is false. So that means HA is true. So we are having a method that is going to save the company money and make those widgets faster and really and boost profits. Okay. But we did not detect that. We failed to reject the false null hypothesis type 2 error. So the new method saves time and money. Yay! That's reality. But we did not get have evidence to detect that. We think that the new method doesn't have a benefit at all. So consequences. There's Bella. She's wanting to be picked up. So, but I'm almost done here. So the manufacturing company, the consequence of that one, they don't retool, and so they miss out on that long run profit. Type 2 error would be, all right, which type of error would you, the engineer, consider more serious? Well, that type 2 error, you're not getting to show off that you came up with this wonderful thing that could improve the company. So you would hate that. Of course, really and truly, I think probably overall the more serious one that we want to minimize the possibility of is that type 1 error, because that is very, very costly to the manufacturing plant, to the company, with no benefit at all. Has no change on that average time to make those widgets. Okay. So that's the end of going over those 3 scenarios. Hopefully, you've got those types of errors straight. And so, our next lesson is going to talk about how can we reduce or change the probabilities of those types of errors. Now that we might identify which ones are worse, depending on the situation. Okay. So now, how can we impact the likelihood of those happening so that the really bad ones have less of a chance to occur? All right, so I'll meet you in the next set of notes.